Inverse matrices and systems of equations. So last chapter we solved systems of equations 3 different ways. We solved them through graphing, through substitution, and through elimination. Matrices is yet another way to solve systems of equations. And so we're going to actually solve them multiple ways. The first way is setting up a matrix equation. So when you have the systems of equations here, x plus 2y equals 5, 3x plus 5y equals 14, you can break it up into a coefficient matrix, a variable matrix, and a constant matrix. First, you have to have them in standard form, meaning your variables on one side and your number on the other. And you want the variables in the same order. So if it's xy, it needs to be xy. All right? So you take all the coefficients, in this case, the 1, the 2, the 3, the 5, that becomes your coefficient matrix right here. And then you have your variable matrix. That is your variables in order from left to right, but you make a column with them. So it's xy. You'll notice it went xy as a column. And then your constant matrix is what it equals, 5, 14. And what you just did for bell work, you should know how to solve for this matrix. Find the inverse, multiply the inverse by this guy, you have your x and y. All right, and that is the solution to that systems of equation. If you were to solve it by graphing or substitution or elimination, you would get the same answer. All right, it's just yet another way to solve this. So let's look at first separating these out, writing it as a matrix equation. So the first thing you want to do is just make sure you know how to separate them out. We're not going to do these individually, so we'll just do these examples right here. If I want the coefficient matrix, I'm going to take the 3, the 2. What do you think I'm going to put right here? 0 and 1. My variables are x and y, and my constants are 16 and 5. 3 by 3 works exactly the same. I'm going to say 1, negative 1, 1, 1, negative 2, negative 1, 2, negative 1, 2. In this case, I'm going to have an x, a y, and a z. And then I'm going to have a constant 0, 5, 8. We're not solving at this point. We're solving in a minute. We're just setting them up. All right, so setting them up, you have a coefficient, a coefficient, a variable, and a constant matrix for these. All right? So make sure you set up your coefficient matrix, your variable matrix, and your constant. Find your determinant, find your inverse, multiply the inverse by the constant, and you have found your variables. It needs to be in a point form when you give the answer, XY form. All right, let's look at the first one. So you should have set up your coefficient matrix 5, 3, 3, 2, variable matrix, and your constant matrix. Then you're going to find your determinant. 5 times 2 is 10. 3 times 3 is 9. So they were nice. Gave us an easy determinant of 1. So switch your 2 and 5. Negate your 3. Multiply by your constant matrix. Row by column. 2 times 7 is 14. Negative 3 times 5 is negative 15, which is going to give you your negative 1. The negative 3 times 21 is negative 21, plus 5 times 5 is 25, which is going to give you your 4. B, coefficient 1, 3, 3, and 2, variable and constant. All right, determinant. 1 times 2 is 2, minus 3 times 3 is 9. Your determinant is negative 7. So 1 over negative 7. Switch your 2 and 1. Negate your 3's, which is going to give you negative 2 sevenths, positive 3 sevenths, positive 3 sevenths, and negative 1 seventh. Multiply by 22 over 10. All right. Then we're just going to multiply row by column. Negative 2 sevenths times 22 is negative 44 sevenths, plus 3 times 10 is 30 sevenths, which is going to give you negative 14 sevenths, which gives you your negative 2. Then we have 3 times 22 sevenths, which is 66 over 7, plus a negative 10 over 7, which gives you 56 over 7, which also gives you your 8. All right, so Cramer's rule. This is a rule that uses 2 by 2 determinants to solve. And so you have a determinant for your coefficients, and then you have a determinant for your x and your y, and if you have a z as well. And then you just use those to solve. And so you're doing a bunch of really simple 2 by 2 determinants here. So I take my coefficients, a, b, c, and d here, and I find that 2 by 2 determinant. And then I replace the first column, my x column here, see my x column, with my answers, m and n. Then I find that 2 by 2 determinant. Very easy. Then I go back to this guy and I replace my y column with my answers. And I do a 2 by 2 there. And so I have 3 determinants, just 3 2 by 2 determinants. And now I just divide to solve. My x is going to equal my x determinant over my coefficient. And my y is going to be my y determinant over my coefficient determinant. All right? It's pretty straightforward. So let's do it. All right, use Cramer's rule to solve. So I'm going to first set up a determinant for my coefficients. My coefficients are 3, 2, 1, and negative 1. All right. So how do I do this? Well, 3 times negative 1 is negative 3 minus 1 times 2, 2. So my determinant here is negative 5. All right. Then I am going to do a determinant for my x's. So I'm going to replace my x column with my answers. So I'm going to say 0, negative 5 in that column and leave the other one the same. And then I'm going to do this determinant. 0 times 1, 0, minus negative 5 times 2, negative 10. So this determinant is 10. All right. Then I'm going to do the same exact thing with my y. I'm going to leave the x column the same, 3, 1. Oh, don't bounce on me. 3, 1. And then I'm going to replace the y column with the 0, negative 5. And I'm going to do that determinant. So I'm going to say 3 times negative 5 minus 1 times 0. 3 easy determinants, right? To find my x, y, I'm just going to take those determinants and I'm going to put them over my coefficient one. So I'm going to take this 10 divided by that negative 5. That gives me negative 2. I'm going to take this negative 15 and divide it by that negative 5. That's going to give me 3. My answer is negative 2, 3. All right, so you're going to find your regular coefficient determinant first. So 3, 1, 2, 3. So we have 9 minus 2. That guy's going to be 7. Then we have our x. So replace my x column with the 5, 8. So we have 15 minus 8. That's 7. So this is going to be 7 divided by 7, or 1. And then we have our y one as well. 3, 2, 5, 8. So we have 24 minus 10. That's going to be 14. So this one's going to be 14 divided by 7. So honestly, when you have a 3 by 3, you can do it exactly the same, but you're going to have 4 determinants and they're all 3 by 3s. So it's a little bit more time consuming, as you can imagine. I would do exactly the same. I would have a determinant for my coefficients, which in this case is like 0, 1, 4, 1, 1, 1, 2, negative 5, 0. I'd have to do that guy. And then I would have to do 3 different ones. I'd have to do an X and replace my X column. And then I'd have to do a Y and a Z, right? So while it is time consuming, it is doable, right? I mean, I will say there is no easy way to solve a 3 by 3. Like even if you do elimination, think about when we did elimination. You had to eliminate 2, then you had to go back and solve there is no fun, easy, quick way to solve 3 by 3s really. And so Cramer's rule works as well. You just have to do a 3 by 3 determinant. Get this determinant, get that determinant. Again, you're going to put the X determinant over your original. You're going to put the Y determinant over your original. You're going to put the Z determinant over your original. And you'll have an X, Y, and a Z. Do you have to do all 3? No. But you do have to do enough that you can solve for your other variables. In this case, they were really kind. I have a 0, a Y, and a Z. So which one would you solve for first? It really doesn't matter because they gave you a 0 down here. So let's say I solve for my X. Do I need to go through a 3 by 3 to solve for my Y? What do I do? Plug it in, right? So honestly, once you have this, you can plug it in. Now, if they did not give me these zeros, I would have to at least do 2 of them, okay? So if they didn't give me the zeros, you'd have to at least do an X and a Y or whatever. But they gave me a 0 here. I could do this determinant and solve for my X. And then I can just plug it back in, right? And solve for Y. And then once I have X and Y, I can plug it in and solve for Z, right? And so once you have enough room to solve for your other variables, no, you don't have to go back through and solve, right? I just think on the 2 by 2, it's just as easy to do another 2 by 2 determinant than it is to plug it back in and solve, personally. But yes. Your goal for an augmented matrix is actually to use the identity matrix to solve these. And so you set up not multiple matrices, but you set up one. And you use your coefficients, negative 6, 2, 4, 0. And then you do this line and you put your answers over here. Okay? And your goal with this one is to make the left side look like the identity matrix. Well, first of all, let's review. What is the identity matrix for a 2 by 2? Well, identity has your rows as 1, 0, 0, 1. Your diagonals are always the ones. All right, that's your identity matrix. So your whole goal is to make this left-hand side look like him. Okay? You can do a couple different things. You can switch your rows. You can completely switch the rows because it doesn't matter if one XY, equation is on top of the other. So you can switch your rows completely. You can divide everything in a row by a number. You can multiply everything in a row by a number, or you can add 2 rows together to get rid of something, almost like an elimination. All right? And then once you have your identity matrix on the left-hand side, you have your answers on the right. Okay? So I'm going to look for the path of least resistance. I'm going to say, where's my easiest place to get a 1? Well, my easiest place to get a 1 is going to be this row. Why do I think that's my easiest place to get a 1? I can multiply, divide, or add 2 rows together. What can I do to this row to make this one of these a 1? Divide everything by 4. And so if I divide row, well, that's not how you spell divide. There you go. Row 2 by 4, or multiply by 1/4. So I'm going to do that. I'm going to leave this guy alone, and I'm going to divide everything down here by 4. Now remember, I want the identity matrix, so where do I really want that 1, 0? I want it on the top. Well, one of the things I can do is switch rows. So what do you think I'm going to do next? Yeah, I'm going to switch row 1 and row 2. All right, so I'm going to say 1, 0, negative 5. Switch the whole row. Negative 6, 2, and 10. Now here's where it gets a little tricky. The bottom row is not going to easily divide, and even if it does, you're not going to get rid of a 0. And so what you can do is you can temporarily multiply a row by something and add it to another row to do this. So what I would do is I would temporarily multiply that top row by 6. All right, because I really need this guy to be a 0. If I don't make him a 0, then he's going to mess up my 1 when I start doing other things. So I'm going to temporarily multiply this top row by 6. So I'm going to say this is a 6, this is a 0, this is a negative 30. I don't do it permanently because I can divide it right back out. We know we can multiply or divide them out, right? And then I'm going to add that to row 2. All right, so my new guy looks like this. 6, so I'm going to leave this alone because basically I'm going to multiply the 6 in and divide it back out for this process, okay? So multiply him in to do the addition, but divide him back out, which means he's going to end up being the same. So I'm going to say the top row is going to stay 1, 0, negative 5. The bottom row is going to be the 6 plus the negative 6. That's going to give me a 0. It's going to be 0 plus 2. That's going to give me a 2. And then it's going to be negative 30 and 10. So that's going to be negative 20. All right. My final step, so I basically have a 1, 0, 0. Now what do I need him to be? I need him to be a 1. How do I get him to be a 1? Divide by 2. Divide by 2. And so I'm going to divide row 2 by 2. All right? Which means I'm going to have 1, 0, negative 5. 0, this divided by 2 is 1. This divided by 2 is negative 10. All right? So for this one, we're going to say 1, 2, negative 1, 2, 5, negative 4. I already have a 1 where I need it, okay? So I'm going to use this 1 to get rid of everything below it, get rid of the 2. So what do I need to multiply this row by to add it to this guy to get rid of my 2? Negative 2, right? So 1 times negative 2, 2 times negative 2, negative 1 times negative 2. Okay? So I'm going to multiply row 1 by the negative 2 and add it to row 2. This is just a temporary multiplication. I'm going to divide it right back out. So this new 1 is going to look like this still because I will have just divided him back out after I do that addition. So I have negative 2 plus 2 is 0. Negative 4 plus 5 is 1. 2 plus negative 4 is negative 2. All right? So actually what that did for me is that gave me a 1, 0, and a 1 where I want it, right? I want this guy to be a diagonal of 1s and everything else 0. So that actually helped me out more than I thought it would, okay? If it had not done that, I would have just taken whatever this number was and divided across to get that to be a 1 because I already have a 0, okay? So now I have a 1, 0, and a 1. I want to use this guy to zero out the thing above it, right? So what do I need to do this second row? Multiply by negative 2. So I'm going to multiply row 2 by negative 2 and add it to row 1. You'll notice that because I zeroed it out, this 0 is not going to hurt me when I add it back up. That's why you zero everything out below your 1s or above your 1s when you have it. This is going to be negative 2. This is going to be positive 4. So this means my bottom row stays the same. And I'm going to add these numbers to my top row. So 0 and 1 is 1. Negative 2 and 2 is 0. 4 and negative 1 is 3. And I'm done. My answer is 3, negative 2. So look, I already have, listen, when they set this up, they already gave you a 1 here, right? So I don't even need to multiply this by anything, right? To add it to this guy, it's going to zero it out. So my first step here is just to add my row 1 to my row 2 and leave my row 1 alone. So I'm going to say 1, 1, negative 10. And then 1 plus negative 1 is 0. 1 plus 1 is 2. Negative 10 plus 20 is 10. All right, so now once I have my first column done, 1, 0, I'm going to move on to my second column. I need to get a 1 in the diagonal. Right, so now what do I need to do? Well, I need to get rid of this 2 and make it a 1. How do I do it? Divide by 2. So I'm going to divide row 2 by 2. Leave row 1 alone. 1, 1, negative 10. 0, 2 divided by 2 is 1. 10 divided by 2 is 5. My last step is to get rid of this 0, this 1 up here. So I need to temporarily multiply this by what to get rid of this guy? What do I need to multiply this by to get rid of him? Negative 1. So multiply row 2 by negative 1. So this is going to be 0, negative 1, negative 5. Leave row 2 alone because we're just going to divide that guy right back out when we're done. And then I say 0 plus 1 is 1. Negative 1 plus 1 is 0. Negative 5 plus negative 10 is negative 15. And my answer is negative 15, 5.